Hello children. So I'm back again with a new video, and it is based on the topic rocks. So let's start with the topic now, and before I start with it, I want to remind you, as always, do subscribe this channel, and don't forget to share the link of this video with your friends and classmates. So now let's continue with it. First of all, rocks and minerals we have to discuss here. Basically, rocks, how we can define rocks. Rocks can be defined as an aggregate of minerals, okay, and that forms more or less a definite unit of the earth's crust. Outermost layer of the earth is called crust, and actually different type of rocks are forming the crust. Now the term rock refers not to any hard solid matter like granite, but also to soft and loose particles like sand, silt and clay. These are also called rocks, okay. So basically we can say that outermost layer of the earth, the crust, is formed of different type of rocks. Earth's crust is made up of various structure, color, permeability, mode of occurrence and degree of resistance to denudation, okay. But when we talk about the different rocks, we can say that rocks consist of different mineral elements, right? And you know, scientists have identified more than 2,000 mineral elements on the earth, but only a few are important as constituents of rocks. So we can distinguish between the rocks and minerals. Now, what are the basic differences between the two? On one side, rocks these are the aggregates of mineral elements, right? They are made up of several minerals altogether. And whereas on the other side, minerals are inorganic substances occurring naturally, okay? This is the first point. Second point is that a rock has no definite chemical composition. Again, very important point of difference between the two. But minerals have a definite chemical composition, right? Now come to the third point. Minerals are organized, or you can say minerals together come to form a rock. But on the other side, minerals are formed by various elements. So three chief type of rocks are the different types as we study: the igneous, sedimentary and metamorphic rocks. And the basic type of minerals what we find are silicates, carbonates, then sulfides and metallic minerals, okay. Examples, if you take, like in the case of rocks, we can give the example of basalt, granite, sandstone, slate, quartz, marble. All these are the examples of rocks. But on the other side, minerals: iron, silicon, magnesium, nickel, potassium, sodium, right? All these are the minerals, the most important minerals which are forming the earth. Now come to the next one. Basically in geology, you will find what is geology? Geology is the study of rocks, okay. So in geology, rock or stone is a naturally occurring solid aggregate of one or more minerals. And a rock is an aggregate of minerals, you can say. So it may be out of one mineral or more than one, right? And classification of rocks, as I said in the earlier part: igneous rocks, sedimentary and metamorphic rocks. And the examples of each has been given here. Igneous rock, one of the example you can see here in the pictures. The best example of igneous rock is basalt, okay. Sedimentary rock, the same way, limestone, okay. And metamorphic rock is gneiss. So these are the examples of it. Now let's talk about the first type of rocks, that is igneous rocks. Now, from where the word has come, igneous means something related with fire, because the word itself has come from the term ignis, okay, a Latin word, that is ignis, which means fire. So we can easily relate that on earth, any rock which is formed out of the molten, you can easily imagine it's burning hot molten magma or lava, right? So whenever it cools down, that forms igneous rock. Okay, so the other way we can say that these rocks are formed due to cooling, solidification and crystallization of hot molten magma or lava. Why I'm saying magma or lava? Because when it happens below the surface of earth, that is inside the earth's surface, right? That is actually called as the intrusive igneous rock, when it is formed by the solidification of magma below the earth's surface. And when it is coming out on the earth's surface by any volcanic activity also, and it is then called, the same molten matter then is called as lava. And when lava solidifies on the surface of earth, that forms an extrusive igneous rock. Okay, so that's why you should be very careful when you explain. The intrusive igneous rocks are formed by molten magma below the earth's surface. Extrusive igneous rocks are formed on the earth's surface by lava. I hope this is clear to you. And the examples of such rocks can be granite, basalt and all. Granite is the example of intrusive rock. Basalt is the example of extrusive igneous rock. And among the different type of rocks, igneous rocks especially, these are most abundantly found, right? And basically, these rocks are called by the name primary rocks. Why? Because the reason is, it is believed that in the beginning, when the earth was originated and it got its origin, and at that time earth started cooling down. Okay, very fast it started cooling down, and as it cooled down, so the first rock which was formed on the earth, just imagine of the molten magma or lava by which the earth is believed to be formed of in the beginning, right? And when it cools down, naturally magma or lava forms which type of rock? Igneous. So it is believed that in the beginning this was the only rock which was formed on the earth, and then afterwards, by the sediments which were coming out from this rock, or by conversion of this rock into the other type, then resulted into sedimentary and metamorphic. So that's why this type of rock is also called as primary rocks. Now let's talk about the characteristics of igneous rocks. Now basically, when we say the igneous rocks, what are the main features? Basically, these rocks are very hard. Okay, these are very hard and resistant rocks, and these are very strong also. They are made up of interlocking crystals that have grown into each other and lock together, and thus forms these result into a very hard and compact rock to be formed out of it, right? So igneous rock has got this feature. Then when we say the different forms of igneous rock, according to the nature of this rock, or where it is formed, it can be classified into two types. And when I told you just now in the earlier part, whenever you can say the lava is able to come out on the surface and it cools down, it results into the formation of, again, because it is the lava or magma which is forming the rock, so it is igneous, right? But that rock which is formed on the surface, that is called as extrusive igneous rock. And when the magma on solidification below the earth's surface, actually it results into the intrusive igneous rock. So now the extrusive rocks occur as simple lava flow, but intrusive rocks on the other hand assume different forms or shapes, which in turn are influenced by geological structures occurring in the country rocks and fluidity of magma. So in this case, you can see here by a simple picture, I've tried to show you this. This is actually the difference. You can see basalt and granite, right? This is granite, this is basalt. The difference you can see. Now that is the extrusive and intrusive rocks. Same way, how these are formed, you can see here very clearly, it's shown in this picture. Extrusive igneous rock formation is where? It is on the surface always, right? And the intrusive igneous rock is formed in which part? Below the earth's surface, you can see here. That is in between the rock layers. Clear? So this is actually the formation of igneous rock in two ways, and that is how we classify these rocks into extrusive and intrusive rocks, right? Now, forms of extrusive igneous rocks, a rock formed out of volcanic dust and ash is called volcanic sand. Okay, volcanic dust and volcanic ash. And a rock formed out of volcanic dust and ash is called tuff, Tuff, right? And another one, volcanic agglomerate, or you can say volcanic breccia, right? It is actually the small particles of it, or the you can say small stones. Okay, they all come together and they are together called as the pyroclastic material, right? Now the solid matter which comes out of the volcanic eruption, all that is pyroclastic material, and it can be the ash, it can be a small stone like particle, that is called the, yes, that is called lapilli. And a big sized particle that comes out generally, like we can compare that with a tennis ball, okay, lawn tennis ball, or the cricket ball, just like that shape. So that is called as the name given to that is the volcanic bomb. So these are the things coming out of it, and they result into the formation of one rock together then, right? They all come together, and when they come together, they form one single rock, and they are called as the extrusive igneous rock, okay, formed of pyroclastic material. Then you can see here forms of extrusive igneous rock in different ways. These are shown, and on this side, the right side, the picture has been actually shown in both ways, you can see. Now these are the particles thrown out by volcanic activity, okay, and the other side, inside the earth, or you can say below the earth's surface, the granite is present, granite is formed, right? So this is how these are actually formed in two ways, right? Now come to the next one. One more classification is done regarding the igneous rocks, the igneous according to their chemical composition. Okay, as you all know that silica content in the magma or lava, it's very high content of silica we can find there, right? So according to the content of silica and the, you can say, oxides of heavy metals, we can classify the igneous rocks into two types again. One is acidic igneous rock and the other is basic igneous rock. Okay, now what is acid igneous rock? Acid igneous rock has got a high content of silica, almost 65 to 85 or 90% of it. Okay, that is only silica, and besides that, the rest of the percentage is covered by any other matter, or especially the oxides of heavy metals like iron and magnesium and all. Okay, so that is called the acid igneous rock. What is basic igneous rock? In basic igneous rock, the percentage of you can say silica goes down. Okay, in this, the percentage of silica is almost 40 to 50%, or maximum it reaches to 60. Okay, that is the silica content. And what about the other oxides of heavy metals? They are covering the rest of it. Okay, so the oxides of heavy metals are more in percentage in the case of basic igneous rock. Same way, if we talk about the acid igneous rock, these are lighter in color as compared to basic igneous rock, and they are lighter in weight also. But if we talk about the basic igneous rock, you can see in front of you the examples of it, right? So basic igneous rocks are always dark in color, they are heavy in weight also. Okay, you can see the difference, granite, and this is basalt, this is gabbro, another basic rock. So these are the basic you can say differences between the two. Now what about the intrusive igneous rock? As we have seen, intrusive igneous rocks can be formed below the earth's surface. Okay, so when the magma solidifies within the earth's crust, it cools slowly, forming coarse textured hard rocks with large crystals, and then it results into the formation of granite and dolomite like rocks. Okay, always keep this in mind. Below the earth's surface, when it is formed, intrusive rocks, they have coarser sized particles, coarse particles, or you can say coarse means big sized particles are there. Okay, but if you talk about the extrusive rocks like basalt and all, in that case, because they cool down fast, so their particles are very fine. Okay, the crystals are very fine. Understood? So in this case, regarding the intrusive igneous rock, these are having coarse textured hard rocks with large crystals. Okay, and moreover, when we talk about the different types of intrusive igneous rocks, we come to know about different terms like batholith, laccolith, sill, dyke, neck. What are these now? So as we all know that it is formed below the earth's surface, so naturally all these formations are seen below the earth's surface only. Okay, now what is the meaning of it? Actually, lith means rock. So when we say batholith, bathos means the depth. Okay, so batholith means a rock, intrusive rock, which is found at greater depth. You can see here, suppose a small magma chamber is there inside, okay, deep inside, and within the magma chamber only somehow the magma cools down and it solidifies. So when it solidifies, that rock which is actually covering the magma chamber itself, that is called as the batholith. You can see the first one from below. This is batholith. Okay, number one. Number two is laccolith. Laccolith always has got a dome like shape. Okay, here in this picture you can see this one. This is laccolith, right? Now what is laccolith? Basically, again, it is a type of intrusive igneous rock, but according to its shape it is called by different name. Okay, this is laccolith. Is actually, it has got a flat base and the upper part is dome like shape. Okay, same way dyke and neck, these are almost vertical, you can say pillar like structures, which are formed by the solidification of magma in the vent itself, right? And when the solidification occurs in horizontal form in between the different rock layers, you can see here, this is called as sill, S-I-L-L, right? So these are the different forms of igneous rocks. Let's see how all these are formed. The deeper the intrusive rock, the longer the cooling time and the larger crystals are formed. Okay, so out of all these you will find the batholith has got the maximum, you can say its particles are bigger than any other. Now come to each one of these. Let's discuss now dikes first of all. Okay, dikes and sills, these are the most common forms of igneous rocks. And dikes, dikes are steeply inclined igneous rocks, and they are like narrow in width and have nearly uniform thickness, right? And they occur cutting across the bedding planes of the country rocks in which they are found. In this picture you can see dyke is here, right? This is dyke. So these are vertical structures, pillar like structure. Next is sill. Sills are similar to dikes in being sheet like intrusive bodies, but unlike dikes, these are concordant, or you can say sills are formed due to the penetration of magma into the bedding planes of country rocks. Okay, in between the rock layers, suppose a space is there, a thin space, so in that the magma tries to get in, and there it cools down, and that results into the formation of this rock, which is called sill. Okay, so its temperature and the weight of the overlying rocks, actually you will find now basic magmas being more fluid and more hot usually occur as sills. Okay, during sill formation, the ascending magma under great pressure pushes the overlying rocks upwards and accommodates itself by intruding and spreading along weak bedding planes. So this is how the sill is formed. Now come to the next one, laccolith. Laccolith is again you can say an example of intrusive igneous rock. Okay, you can see the examples in front of you very clearly in this picture, right? This is dyke, number one. These horizontal parts are called sill, and this is the laccolith which we are talking of, right? You can see a dome like structure is there. Okay, dome like structure, and especially you'll find the upper part is actually convex shape is there, and the base is always flat, so that is always called as laccolith, right? This gives the shape of an inverted bowl, right, to the igneous body. This is laccolith. Now comes the neck and dike. These are the igneous bodies which seal the vents, okay, or the conduits of ancient volcanoes. Now these are somewhat cylindrical in shape, okay, and volcanic necks are also called as volcanic plugs. Many times these necks, these are found as you can say these are formed in just straight away in that vent only, which doesn't allow the magma to go out. So these are actually called as plugs, which are actually blocking the way. Okay, now next one, this is one of the examples of volcanic neck. Now let's move to the next one, batholith, which I told you in the beginning, the first intrusive rock when we were discussing. So batholith is basically, these are the largest known intrusive igneous bodies, characteristically occurring in mountain regions. Okay, they have sides sloping away from each other, which makes them larger and larger downwards and then extended to very great depths, right? Since they are deep seated, only very prolonged erosion exposes them on the surface. Otherwise, maximum time they remain below the surface only. Now the next type of rock we have to discuss here is the sedimentary rock, okay, or you can say the secondary rocks. Now what is the meaning of sedimentary rock, how these are formed? You can see this is the first process of its formation, layer by layer deposition of sediments that results into the formation of sedimentary rocks. Here again the sediments are joining actually these are falling back in any water body, and they are deposited at the base of it, and thus these result into the formation of a sedimentary rock again, right? So basically sedimentary rocks are the rocks which are formed by the deposition of sediments. And what sediments? From where we get these sediments? These sediments are coming from the pre-existing rocks only, right? So these are formed by the sediments which are being taken by any of the agents of gradation from the different rocks, and these are deposited somewhere else, and thus layer by layer deposition results into a type of rock to develop out of it, and this rock is called as a sedimentary rock. Okay, so it actually contributes about 8% of the total volume of the crust of Earth. Okay, now come to the meaning of it and what is actually how these are formed. Now first of all, sedimentary rocks are those which are formed out of sediments, right? Number one. Number two, sediments are rock fragments which are product of weathering. Okay, and weathering has already been defined as natural processes of disintegration and decomposition of rocks. So after weathering, these particles are taken away by any agents and deposited somewhere else. This results into the formation of sedimentary rocks, right? And basically this crust is mainly made up of sima and silica. Sima is the underlying portion of the ocean floor, and sial is the overlying granitic portion forming the continental part. So above these lies a thin layer of sedimentary rocks covering large tract of the surface. This sedimentary layer is discontinuous and of varying thickness. Somewhere it is very thin, somewhere it is quite thick. Okay, so quantitatively, if you see, sedimentary and the related rocks together constitute only 5% of the Earth's crust. The remaining 95% being igneous rocks and their metamorphic equivalents, you can say. Okay, so altogether it is just covering 5% of it. Now sedimentary rocks on the Earth's crust, how we can find? You can see here on the Earth's crust how these are formed, right? And these are actually of different types. the limestone, shale, sandstone, all these are the different types of sedimentary rocks. Now, the type of rocks that are formed by the deposition of material at the earth's surface and within the bodies of water. Okay. Then indicators of geological processes, environment and geological history. Then they contain mineral resources such as coal, petroleum, natural gas, iron, gold, aluminium, uranium, diamond. All these are found in the sedimentary rocks. Okay, so these are a few important features of it. Now the next thing we have to discuss is the formation of sedimentary rocks and what are the different processes involved in it. Okay, so let's start with it. Now number one is weathering, then erosion, then transportation, deposition, right? These are the various you can say stages in the formation of sedimentary rocks. So as we know that sedimentary rocks are formed by the deposition of sediments which are brought from the different rocks by various agents of gradation. So if the weathering doesn't take place, what will happen? There will not be any particle then. Okay, and if no particles are being carried by any of the agents, so what will happen? No material will be there which will result into the formation of sedimentary rocks. Okay, so for the formation of sedimentary rocks, it is required that any rock is present beforehand, right? Any pre-existing rocks are there which are weathered, which are broken down into smaller particles, and then these particles are then taken away by these agents and deposited, and that results into the sedimentary rocks, right? Now what are the characteristics of sedimentary rocks? Basically, sedimentary rocks are considered as soft rocks. Okay, these are formed when the sediments are pressed and cemented together, or when minerals form from the various solutions. Okay, these are loose materials such as rock fragments and all, mineral grains, and that have been moved by wind, water, or glacier. Okay, all these agents. And sediments come from already existing rocks, that you should keep in mind. Okay, that are weathered and eroded, and then the deposition take place, forming the sedimentary rocks. Okay, and in maximum cases sedimentary rocks are formed near water bodies. And a few important features are also there. Sedimentary rocks generally have the layers within them. Okay, and that's why these are called as stratified rocks also. Strata means the layers. So when we say stratified rock, that means we are talking of the sedimentary rocks, right? And always you will find the fossils, if you remember the fossil fuels, right? The petroleum, petroleum and natural gas and all these, and even the coal, all these are found in between the sedimentary rocks because these are the fossils, right? And because layer by layer deposition take place, so the formation of fossil can be made possible. Fossils cannot be found in the igneous rocks or metamorphic rocks also. In very rarest of the rare conditions, you'll find the fossils are seen in the metamorphic rocks, otherwise not at all. So igneous rocks also, it cannot exist, right? So only sedimentary rocks are there in which the fossils can be seen. So naturally fossil fuels, it will be found in the sedimentary rocks only. Okay. Now how these are formed? These are formed at or near the earth's surface by accumulation and lithification of fragments of pre-existing rocks, or by precipitation from solution at normal surface temperatures. The other way you can see here in the second picture, these are the sediments. Okay, as they settle over one another, right? They are actually, these get settled and water and air is squeezed out of it, right? Because of the compaction. This process is called the compaction because of the pressure which is exerted from the upper lying layers. This type of rock is formed. And in one more case, you can see cementation. Cementation means some other element is involved in it which works just like a cement. What is cement now? You all must be knowing about it. Cement is something which we use for holding the rocks together to form the walls, right? To hold the bricks together. Okay, so when we talk about this cementation means some other element is involved which is holding all the particles together and resulting into a sedimentary rock, which is then said as the sedimentary rock is the result of the process of cementation. Okay, I hope this much is clear to you all. Now the processes which are involved in the sedimentary rocks formation, altogether these are called as lithification. What is lithification? Lith, I told you in the beginning that lith means rock. Lithification means the process of formation of rock. Which type of rock? Here we are talking of the sedimentary rocks. So the process of formation of rock from a sediment, the entire process is coming under lithification. So what are the different processes in this lithification? Number one is evaporation, then compaction and cementation. First of all, when we talk about the first process, that is evaporation, in this case water from loose materials is evaporated, as in the case of rock salt. Okay, the accumulation of rock salt mainly taken place through evaporation before being compacted and cemented, right? And that is called evaporation. If any such rock is formed by the evaporation process, like the particles are settled down under the you can say in a pond water, okay, now lake water, and when the lake, suppose due to constant evaporation, the water goes away, right? Now what is left behind? At the base of the lake you will find the sediments actually now are left, and these result into the formation of hard rock then, and these are then called as the result of the sedimentary rocks, which are the result of evaporation. Okay, you can see a few examples of such rocks. These ripple marks are actually showing the motion of wind and water waves on lakes, oceans and rivers and all. These are the ripple marks. Okay, then one example, you can see mud cracks when sediments at the bottom of a shallow body of water, like I was telling you just now. So you can see this type of thing develops at the base of a lake. Okay, so these are again the result of evaporation. Next is compaction. Compaction means compaction means when the particles are settled, right? No such evaporation take place, no such cementation is required, right? Simple settling down of sand particles or the sediments one over the other, and due to the upper lying layers, the lower layers get compact, right? Okay, and that results ultimately into the formation of a type of rock. And in this case you can say that the resultant rock is actually due to the process of compaction. And in this case we can give the best example of sandstone. Okay, sandstone is also a sedimentary rock, and it is the result of compaction, right? Now the third one is cementation. It is the bonding together of compacted sediments, right, by some natural materials like calcium compound, silica, iron. These actually hold all these particles together, and these particles are having a nature of bonding the loose materials together. So the process in which the sediments are glued or stick together after minerals crystallize, and that is the rock which is the result out of it, right? The rock formed out of it, that is actually called as the sedimentary rock formed by cementation process. Okay, so these are the three different processes.